Hi, this is Saka, and here I'm going to help you with the Half-Life problems from Sunday, the weekend's homework. This is page 837. I'm going to help you with 77 through 79. So first I'm going to do 77. Now in 77 they asked you about the half-life of tritium. So they said the half-life of tritium, the half-life was equal to 12.3 years. And you start off with 48 milligrams, so the beginning amount is 48.0 milligrams, and the total time, which I call T, that has passed is 49.2 years. Now I'll do the first part because they also ask you what it is after when time equals 98.4 years as well. But let me just start with this one first. So we can do what we did before. So we can set up, we can say half-life, and then on one column, and then we can say the mass in another one. This is similar to what we did in the worksheet. So at 0 half-lives, that is equal to 48.0 grams. Now, one half-life that has passed, so one half-life, and this is equal to 12.3 years, we lose exactly half of the sample, right? So this becomes 24.0. And then after two half-lives, that's 24.6 years, and you end up with half of that, which is 12.0. And then after three half-lives, that's what, 36.9 years. You end up with 6 milligrams. So this is milligrams, by the way, not grams. And after four half-lives, that's what, 49.2? Yeah, 49.2 years, and you end up with 3.0 grams. So this would be our answer right here. So this would be milligrams. So this would be our answer. And then you could keep going till you got to 98.4. So let me do the second, let me do this one. Let me change colors here. Let me do this one in a different way. So now I'm going to do the 98.4 part. So another way to do this is we can say mass at time equals mass at time 0 times 1/2 to the n, where n equals T over T1/2. So if I know how many half-lives have taken place, I know how many times I'm going to multiply by 1/2. So to do this one, for the second part, we could say 98.4 over 12.3. So if you take 98.4 and divide it by 12.3, and I'm doing that right now, we end up with 8 half-lives. So we could keep going another 4 times using the first method, or we can use this one. So we could say 48.0 times 1/2 to the 8th. That will also give us our exact same answer. So let me do that. 48 times 0.5, where's my little caret, to the 8th, and we end up getting 0.1875 milligrams. If we rounded, this would be really 0.188 milligrams. I'd accept either one, but this one is the more correct answer with sig figs. So this is for the first part, and this is for the second part. So now let's go ahead and let's move on and do 78. So I'm going to switch the page here. So now let's look at 78. In 78, they say technetium has a half-life of 18 minutes. So T1/2 equals 18.0 minutes. And it says how much, so we have the original amount is 165.0 grams. How much remains after 90 minutes? So the total time is 90 minutes. So we want to know what the mass is after 90. So again, I'm going to use my same equation as before, so because it's a little bit easier. So the mass at 90 minutes will be equal to the original mass at time 0 times 1/2 to the n. And remember, n equals t over t1/2. So let's go ahead and put in those numbers. We have 90 divided by 18. And let's see what that gives us. And that equals 5. So 5 half-lives have passed. So you can go ahead and divide by 1/2 5 times, or you can go ahead and use this equation. So this would be equal to 165.0 times 1/2 to the 5th. And so let me multiply that out real fast. 165 times 0.5 to the 5th. And I end up with 5.16 grams. Okay? Or again, you can take 165 and you keep dividing it. You can divide it by 1/2 5 separate times, and you'd end up with about the same answer. And either way is acceptable. The last one is 79. So 79. Manganese 56 decays by beta emission, has a half-life of 2.6 hours. So the half-life is equal to 2.6 hours. How many half-lives are there in 24 hours? So if T equals 24 hours, what is the number of half-lives? So that's basically asking you what N is equal to. So N equals big T over the half-life. So 24 divided by 2.6 gives us about 9.23. So here's an example of one where we don't have an exact number. I mean, this is not a whole number. Okay, but let's go ahead and do the second part. So it says how many milligrams of a 20 milligram sample. So the original mass is 20.0 milligrams. We want to know how much will be left after 5 half-lives. So if N equals 5, what is the mass after 5 half-lives equal to? So again, we can use you can divide by 1/2 5 times, 10, 5, 2.5, and so on. Or you can go ahead and use the equation. So the mass after 5 half-lives is equal to 20.0 times 1/2 to the 5th. Either way, you're going to get the same answer. So 20 times 0.5 to the 5th. And that equals 0.625 milligrams. And if you divide it by 1/2 5 times, so for instance, if we go 20, so this is at 0, then we have 10. After 1 half-life, after 2 half-lives, there's 5. 2.5 after 3 half-lives, and then 2.5 divided by 2 is equal to 1.25. After 4, and then after 5, it's 0.625. So proof that both methods work. And this is Saka, and enjoy, and if you have any questions, come see me in class.